Hello guys, so my name is Amit. So today we are going to start our system design journey, right? So today we will start learning how you can design your system and how you can deploy your system. So where exactly our system gets deployed? System means application. So where exactly our application gets deployed? To a particular server, right? Now for your applications, which server you need to choose, that is a big thing, okay? So which server you need to choose, that is a very big decisions you have to take, okay? So now choosing a server, how you can choose your right server for your right applications. So before that we need to understand what is the server configurations. So there are couple of parameters you have to know about the server configurations. One is CPU, another is RAM, another is disk size or disk type, another is the network bandwidth and another is the throughput, right? So what is CPU? CPU means it's kind of a brain of your machines or server. So that means, the more CPU you will have, right? Sorry, the more core in your CPU you will have the more power to process, requests simultaneously. So in your CPU, what happens, right? CPU has multiple cores. Suppose you are having 4 cores CPU. That means your CPU can process 4 multiple threads simultaneously, okay? So suppose you are having 8 core CPU, that means 8 parallel threads, right? 8 parallel threads your CPU can handle. So the number of threads gets increased, so the number of parallel processing gets increased, that means the number of requests your server can process will definitely get increased, right? So while you choose your server, you have to choose what is the number of core your CPU is having, that is the main important thing. So next thing is RAM. RAM means what is the specification of RAM? What RAM is used for? RAM is somewhere where a temporary data gets stored while a process or task gets processed by CPU. So when CPU is processing a task, the temporary data the CPU have to store while processing a task is the RAM, okay? So RAM is the place where CPU is storing temporary data, okay, to process one task. So suppose your RAM is, if your RAM size is less, that means, even though your CPU has suppose 10 core, but to process multiple, suppose 1000 requests, the temporary data that your CPU has to store in RAM if your RAM doesn't have sufficient storage, then it cannot store. So that means along with your number of core in the CPU, you have to choose a high size RAM so that multiple processes or multiple tasks can be performed by your CPU. So your RAM size also plays very important role while choosing the server. So next, disk, right? So what is disk? Disk means how fast your server can read or write data, right? So whenever a CPU is processing, right, at a request, your applications is writing a data into hard disk, right, into hard disks. So now what your CPU is doing, either your CPU is reading or writing data into the hard disk, right? So if the hard disk type is SSD, right, there are 2 types of hard disks, one is SSD, another is HDD. So in SSD you get 500 Mbps. 500 Mbps means 500 MB of data your application can read if your hard disk is SSD, right, if your disk type is SSD. But in HDD it will be 100 Mbps. So only 100 MB of data your hard disk can read and write, your application can read and write to your hard disk. So when you will use SSD, when you will use HDD, suppose you are choosing a database for your production server, right, where you need faster processing, right, then you have to choose SSD in your database, because if you choose HDD, it will be slower, because your applications will be able to access only 100 MB data per second, right? But if you choose SSD, then your applications will be able to access 500 MB data per second, right? So where HDD can be used, suppose in your applications you want to back up your historical data into some database, there you can use HDD, because for historical data access no customers will be will be patient enough, right, to get the historical data. But if he wants to check the recent data, he will not be so much patience, right, he will not have so much patience. So for production database you can use SSD, but for historical backup database you can use HDD instead of SSD. Okay. So disk type also plays a very important role when you choose your server. Another is network bandwidth. Okay. So what is network bandwidth? The maximum amount of data, that can pass through the network per second, right. So the maximum amount of data, the network. So you are connecting to a server, right. So how you will connect through a server? To a network channel, right. So through a network channel you are connecting to your server. Now what is the bandwidth? The maximum amount of data you can send to the server per second, right, through this particular channel. Okay. So suppose you have 10 GB per second network bandwidth, that means per second you can send 10 GB data to your server through this network channel. Got it? You understand, right? You can think of, this is a parking lot and this is a lane of the road to go to the parking lot, right. So even though you have a very big parking lot, but if only 10 cars can go per second to your parking lot, then only 10 car can come, right. But if the road is bigger enough to come 20 car, then you can accommodate more car quickly, right. You got my point, right. You can see a road kind of thing, just an analogy. Okay. So network bandwidth, if you have bigger network bandwidth, then you can process multiple requests simultaneously much faster, because the data packet can pass through the particular channel to server very quickly. Okay. So another is throughput. Throughput means how much useful data your system actually process per second. So what that means, right? So we have checked, right? So if it is a server and if you have 10 GB per second network bandwidth, that means 10 gigabyte of data per second you can send to the server, right? That is the ideal case. But in actual case, maybe you cannot send the 10 GB because few of the data packets may lost in between, few of the data packets has to reattempt. So how much actual data your system can actually process in real time, that is the throughput, right? So maybe you can get 8 GB per second throughput, even though you have 10 GB maximum network bandwidth, you may not be able to process 10 GB data per second, okay, because your throughput may be 8 GB per second, right, because this is the ideal case, but this is the actual real time you may able to use only 8 GB per second, right. So this is called the throughput. Throughput provides a real time validations of how much network bandwidth or how much data you can actually process per second. So I hope you understand in a summary. So we will check now 4 parameters. One is CPU. So we will think of how many cores we have in our CPU. The more core we have, the more number of requests we can process parallelly, right. So now to process multiple requests parallelly, we need a bigger RAM size, because because RAM is the one where we will store our temporary data while processing one task in the CPU, right. So now to send the request to actual server, to the when the request should be reached to the CPU through a network channel, right. So now the bandwidth decides how much network data packet you can send per second. So network bandwidth is very important. If you have 10 GB per second network bandwidth, that means 10 GB data can reach to the CPU in server per second, right. But if you have lower data bandwidth, network bandwidth CPU, that means even though you have more core, even though you have more RAM, but the request will not reach to the CPU, right, because it has a limitations in the network bandwidth. So network bandwidth is also very important factor you have to think of while choosing your server, right. So these are the 3 important parameter as I can see, right. And another is a disk also, as I said, disk also, because even though you have more core, more RAM, big network bandwidth, but the server hard disk you have choose HDD type. So that means to process a request in your application, so in the read IO operations will happen, read write will happen, it may not able to read and write faster, right. So the applications will take more time to generate response. So that means your throughput will reduce, right. So you have to choose a SDD in production to get the higher throughput limit, because because applications will process much faster in the disk type of SSD. So I hope you understand till now what is the configurations. So I just given an analogy. So just think of the whole applications or whole server is a pizza shop, right? So in your pizza shop, okay, the number of safe, suppose 2 safe is there, that means 2 safe only prepare 2 pizza per second, right? So if you have 10 safe, then it can prepare at least 10 pizza per second. Now to make 10 pizza per second, right, they need to get few things faster, right? They need to get the materials which is required to make the pizza, that means it is there in pantry, right? So the access to pantry should be faster, right? That calls disk, okay? So if it can get the details required to process a pizza quickly from the pantry, then it can process or it can prepare the pizza faster, right? And next is RAM. RAM means you can say the kitchen workspace. If the workspace of the kitchen is very small, right, then it your safe cannot prepare pizza faster, because it has to place multiple things, right, to prepare the pizza. So if he doesn't get space, he needs to wait for it, right? So that means your safe will be not working with full efficiency. So you have to choose a bigger kitchen size, that means a RAM. Okay, you have to choose a bigger RAM, and number of safes should be increased, that means core is increased. You should take more core CPU, that means number of safe will be more, and the kitchen workspace should be more, that means RAM should be more, and the access to pantry should be easy, that means network bandwidth should be, or disk should be high. So if you will use SSD, that means it can get quickly the required details to get the pizza done, right? And then it can use network bandwidth. Network bandwidth means suppose you have prepared 100 pizza, now you have you have the capacity to prepare 100 pizza per second, but you have a door where you are delivering the pizza to the handing over to the pizza to the delivery partner, right? So the delivery partner is waiting and he is getting only 1 pizza per second through this door to outside. Now 100 pizza will come in 100 seconds, right? It will take 100, even though the pizza preparation is very faster, but it is not reaching to the real customer faster, because your door is smaller, that means the network bandwidth. So network bandwidth should be also very high in your pizza shop. Your your delivery door will be bigger, at least you should send 100 pizza per second through this delivery to the delivery boy, right? So that it can actually reaches to the customer. So that's how you can relate. And throughput means how much useful data your system is actually processing, that means how many pizzas is actually reaching to the customer per second, okay? So if everything works well, that means you have a high number of safe, you have the pantry access very good, you have the kitchen workspace very good along with network bandwidth, then your applications or your whole pizza shop will run faster. So just think of it, if any particular system is having all these parameters, CPU, RAM, disk, network bandwidth, everything proper, then only it can it can work with 100% efficiency, right? So this is what you can think of a server configurations. Now I will give you an example, okay? So now I will give you an example. Suppose you have 8V CPU, that means in your CPU it has 8 core. Now how many requests in this this machine can process it, right? Or how much RAM it should have to process your request. So we will have a detailed discussion, okay? Please watch this video till the end. You will get more knowledge, I can guarantee you will get more clarity over choosing a server in future. So just I am thinking you are having a 8V CPU, that means your server is having 8 core, right? So and I am just assuming one request is taking 10 millisecond time to process, okay? One request is taking 10 millisecond time to process your business logic, okay? Only business logic, it is taking 10 millisecond time. So that means in 1 second, how many requests is processed, can be processed? 100 requests, right? So, one in 1 second 100 requests can be processed. So, it is happening with one core, right. So, one core of your CPU can process in 1 second 100 requests. Now, you have 8 core. So, for 8 core, 8 into 100, that means 800 requests your server can process the business logic, right. Whatever, if your request is taking only 10 millisecond time, then 800 simultaneous requests your server can process, right. Now, just think of it. So, we have done a calculations that your server is going to handle 800 requests, simultaneous request, right. But does your server always work with 100% efficiency? The answer is no. Your server will have some of the overheads. So, what overheads? So, what we discussed about only business logic processing time, it is 10 millisecond, right. Now, you have some of the overheads, like you have written the business logic upon a framework, right. Maybe you have used Spring Boot or Python Flask, anything like that. Okay, you have a framework overhead. So, this framework also getting processed in this particular server, right. And some of the other factors also there, like context switching, lot of context switching happens in server. So, there will be some overheads, right. So, we can assume your server will perform with 70% efficiency. Okay, you cannot assume with 100% efficiency because of some of the overheads, okay, unavoidable overheads. So, 70% efficiency, that means 70 into 800 by 100. So, that means your server can process near about 560 requests per second with 8 core CPU, right, with the framework overhead, right, framework and context switching overhead. So, considering you have 10 millisecond processing time for one request, your server with 70% efficiency, it can process, I can say 500 near about to 600 requests per second. So, till then we reach to the conclusions. Now we will think about another thing, right. So, what we talked in your server, your applications is deployed. Now, think of it, maybe your app is talking to one database, right. So, there is a latency, here is a latency. Suppose the latency is, suppose the latency is 5 to 100 millisecond, right. To reach to the database, we have to build a connection to the database, then we have to get the data, then we have to process it, then generate response, right. So, one request to get the response, total how much time it is taking? Here we assume 10 millisecond. So, total it is taking 60 to 110 millisecond, right. So, total latency is how much? Here it is 10 millisecond, here 50 to 100 millisecond, that means total 60 to 110 millisecond. So, on an average I am taking 100 millisecond is the processing time, right. So, for one request, if you have database overhead, you can have 100 millisecond processing time, right. So, now with 100 millisecond processing time, for one request, 100 millisecond processing time. Now, with 1 second how many process? How many requests? Only 10 requests can be served, right. If your applications take 100 millisecond for one request, then it can process in 1 second only 10 requests, right. And 8 core, 8 into 10, that means only 80 requests can be served if the latency is getting increased. So, you got my point, right. So, whenever the latency is getting increased due to database or any other thing, the number of requests it can serve is getting reduced from 500 to 600 to only 80, right. So, latency is a very important factor, okay. I hope you understand now, right. So, now just think of it, suppose one request, okay, one request is having 100 KB of data packet you are sending. For one request you are sending 100 KB of data, and in the response also it is coming 100 KB of data. So that means it is where it is coming, I told you, right, this network bandwidth channel, right. So in this network bandwidth channel you are sending 100 kb and you are getting 100 kb. You got my point, right. So at a time 100 kb of either request or response is traveling through this network channel, right. Now for one request, okay. Now if you send 500 requests, then what will be the bandwidth? 500. So that means 50 MB. So for 500 concurrent request, if you are sending a 100 kb data packet in request or response format, this is an assumption only, then 50 MB is the minimum bandwidth you need, right. So you know, if your machine is having only 1 GB bandwidth, then the machines will, you know, it will be nearly, optimizations will be more than 50%, right. So if your machines is having 8 GB to, you know, 8 GB or, you know, 10 GB network bandwidth, then your applications will be, you know, working very good, but you know, with 2 GB bandwidth also your applications can run. That is what we can understand, you know, assuming 100 kb is the data packet you are sending through the bandwidth. So now just think of it, suppose your applications is taking only 2 MB RAM per request, okay. So one request is taking 2 MB RAM. Now if you are sent 500 requests, then 500 into 2 MB, that means 1000 MB, that means 1 GB, okay, near to 1 GB. So one request, right, if one request takes 2 MB, then for 500 requests your machines should have at least 1 GB RAM to process, right. So if your machines have 2 GB RAM, then it will always reach to the floor, right, reach to the ceiling, right. So better to have 8 GB RAM, right, then at least your machines will always be working below 50% utilization of RAM and it will be very faster. I hope you are understanding this, you know, calculations, right. So now just think of it, you know, we have designed a system where this is the server, this is the applications deployed, and this is the DB, and we discussed this latency is 5 to 100 millisecond, okay, and this is only 10 millisecond, okay. Now here is this game, right, here is this latency, one IO latency, right. This IO latency is 50 to 100 millisecond. So that means this 50 to 100 millisecond, what your CPU will do, your CPU request will wait for the response. That means it will wait for this 50 to 100 millisecond, you know, to get these connections and data to, you know, get this data from DB. So that means this 50 to 100 millisecond your CPU core will sit idle, right. So this happens when you are writing applications with blocking IO mechanism, okay. But if you are having non-blocking IO, that time this 50 to 100 millisecond your applications will not wait to get the connections from DB, and you know, this time, this waiting time, it will utilize to serve another request, okay. So what I am telling, for non-blocking IO, for non-blocking IO framework, what will happen, this 50 to 100 millisecond, when your CPU is actually waiting for the database connection to establish and to get the data from the database, this idle time your CPU is you will utilize to serve another request for non-blocking IO. But for blocking IO, what will happen, it will keep on waiting. So for blocking IO, you are able to serve only 80 requests per second with these configurations of 8 core machine, right. But with non-blocking IO, this 80 requests can reach to 500 requests per second for non-blocking IO, right. You understood, right, because your CPU is not waiting for the database connection to establish, that idle time it is serving the another request. So definitely the number of requests your CPU can process will be highly improved. So for an example, if you are writing your applications using Spring MVC, right, and Flask, okay, Spring Python Flask, right. So this actually supports the blocking IO. Okay. So through blocking IO, what will happen? Your number of requests these applications can process at a particular second will be reduced, because the idle time your CPU will wait for the connections, for the request to be processed, right. But if you use Node.js, Spring Web Flux, right, this provides non-blocking IO. So what will happen? What will happen for non-blocking IO? What will happen if you use Node.js and Spring Web Flux? Your CPU will not wait for the database connections or any other latency. It will be used to serve another request. So your number of requests that can be served will be highly improved, maybe for this one 80, maybe for this one 500. I hope you got my point, right? You got this difference between non-blocking IO and blocking IO. Now you may have a questions now that what we saw with this 8-core CPU, we are able to serve with non-blocking IO 500 requests per second, right, with 8-core machines. So in AWS, maybe we have maximum 192 core machine, right. This is the maximum size of machines a cloud provider is providing. So now with 192 core, what will be the maximum request we can serve? Just I am giving an analogy, that is 24, right. That is, so what is the calculations I told you, right. So this 500 request we calculated based on 10 millisecond per request. So that means one machine, 10 millisecond is one machine, right. So in 1 second, what will be the happening? 100 request, right, for one core. So for 192 core, that means 192 into 100 request, right. So that means 19k request maximum it can process, right. Maximum it can process 119k request, right, with one single machines, right. So that means your applications can maximum serve to 190k request per second. Then how will you design your system which actually process 1 million requests per second? How will you do it, right? So that time you need scaling. So what exactly scaling is? So that means when the number of requests increasing, you have to somehow manage your server, to serve the request. Now we have seen with one CPU, it can serve maximum 192k, right? Then how will you reach to the 1 million? This is where you need to understand scaling, right? So we will read in the second, next lecture what exactly scaling is, what are the type of scaling we use for reaching to the 1 million request. So next lecture onwards, we will understand scaling and other items to reach to 1 million requests per second. Thank you so much for today's video.